Hello and welcome to EGM722, Week 1, Part 2, Built-in Types. So in the previous lesson, we learned that Python is an object-oriented programming language, that an object is the basic thing or building block that Python is working with, and that objects have something called a type. They also have different properties that determine the characteristics of the object, as well as different methods, which we'll talk more about in the lessons to come. So in this lesson, we're going to be learning about the types of objects that Python sort of ships with, if you like. They're the basic structures or the basic objects that we can use when we're programming in Python. There are also we also have the possibility to create or define our own objects or our own class types that we will talk more about in the lessons next week. So the first broad category of built-in types that we will be discussing in this lesson are numeric, or different types that deal with numbers. So Python has three main numeric types. The first of these is an integer, which is abbreviated as an int, and these are whole number positive and negative values. The second main numeric type is something called a floating point or decimal number. It's abbreviated as float, and these are numbers that have decimal places, so they can be whole numbers, but whole numbers that have a decimal place and then either a 0 or multiple zeros after that. The third main numeric type is complex numbers. These are not something that we will deal too much with in this module, but these are a type of number that has two different parts. One is called a real part, the other is called an imaginary part. The real part is a floating point number. The imaginary part is also a floating point number, but it's multiplied by the square root of -1, which is also known as I, which is also known as an imaginary number. So that's a fairly long explanation for something that we're not going to go into too much, but you're welcome to read more about the complex number type in Python, as well as complex numbers more generally. When we are combining different types, the result of the calculation is going to take the definition, or is going to take the wider definition of the two. So for example, if we have an int or an integer and we combine it with a floating point number, the result is going to be a floating point number. If we have a floating point number and we combine it with a complex number, the result is going to be a complex number. We can also see examples where we have two different integers. So here I've given a variable called x, a value of 2, and a variable called y, a value of 3. And if we take x divided by y, you see that the result is a floating point number, again because we're using Python 3 in this example and in the rest of the module. For text data, or for text more generally, Python uses something called a string. So a string is an immutable array of text characters. Now what immutable means is that we cannot modify or change the elements of the string. So if you look at the example here where I totally absolutely made a typo on purpose, you can see that I cannot go back and change the value at this position to change this from I live GIS to I love GIS, because strings do not support item assignment. That is, we can't say whatever the object is or whatever the character is at this position, give it this new value. That doesn't work with strings. They can't be changed like that. If we want to fix typos like this, we have to create a new string. So individual characters of a string, as you can see from this example, are located at something called an index. In Python, arrays and strings start counting from index 0. So the 0th index of a string or of an array is going to give us the first object or the first character in that string. The first index is going to give us the second, and so on and so forth. Once you are used to it, it isn't that much of a problem, but if you're sort of new to it, it might take a little bit of getting used to. In order to access multiple indices of a string, we can do something called a slice, where we are taking the index starting at index n, as in November, and going all the way up to, but not including, the index m, or Mike. If we omit the n, so if we omit the first of these two indices, then we're starting from the beginning of the string, so at the 0 index. If we omit the m, we go all the way to the end of the index. And we can also use negative numbers in indices. And the way that that works is that the negative numbers start counting from the very end of the string. So the string, or the character at the index -1 is just the last character of the string. The index at -2 is the second to last character in the string, and so on and so forth. The next built-in type that we will talk about is a list, which is just a sequence of values that are called elements or items. So we can create this using either square brackets, as you can see here, or by calling a function called list, which just creates a new list with whatever's in the parentheses. The elements of a list can be of any type. So you see here I've gotten a number of different elements in here, because we can also mix the different types. So we have an integer, we have a string, we have a floating point number, and we have another list, because we can also make lists that are nested or have a list as one of the elements of the list. Now, in order to access the individual items in a list, we can access the indices just like we saw with strings when we have a nested list. So for example, here the 0, 1, 2, the third index of this list is itself a list. So if we start with my list and then the square brackets with a 3, that's going to give us this list. If we then add the next square brackets onto this, it will give us the first element of that nested list. If we put a 1 in here, it'll give us the second element of that nested list. If we have another nested list in here, then we just add another index onto the end there. Lists are also mutable, which means that we can change the value or change the elements or the items of the list after we've created it. So here we're attempting to change the second element of the list at index 1 from a string of the numeric representation of 42 to a text representation of 42. And you see that when we run this assignment statement, it doesn't raise an error like it did for strings, and the resulting list has now replaced the item at that index with that new value. The next built-in type that we'll talk about is something called a tuple. So a tuple is something that works very similar to a list. So it can contain multiple types. We can access the index or the individual elements of a tuple using the square brackets like we saw with strings, like we saw with lists. They can also be nested, so we can have a tuple inside of this. We can also have a list inside of a tuple. Those are all fine. We create tuples using commas. So if we just separate variables by a comma like this, then it's going to create a tuple. We can also use the parentheses to create to indicate that we're creating a tuple, and it does the exact same thing. You can also use tuple followed by parentheses in order to create it that way, like we saw with lists. The big difference here is that tuples are immutable. They, like strings, cannot be changed once we've created them. So you see here trying to replace the second element of our tuple with a new value, and we get a type error which says that the tuple object does not support item assignment. This is the same error that we saw with strings because we can't actually overwrite the values of the tuple once we've created it. The last built-in type that we will talk about today is something called a dictionary. So this is very similar to a list or a tuple, but it's significantly more general. So the list indices, as you saw, are always integer values. We always, when we're trying to access the individual elements of a list, we have to put in an integer value corresponding to that element's place in the list. Dictionary indices can be almost anything. So we have a much more general way of accessing the different elements or values within our dictionary. So we can create a dictionary using either the dict function, similar to what we saw with lists or tuples or strings, or we can use curly braces to create a new dictionary. So dictionaries are effectively mapping the indices, which are also known as the keys. So here we see the keys are, in this example, 1, 2, and 3. So we have inside of our assignment statement for the dictionary, we have the curly braces, we have the key, we have a colon, and then we have the value corresponding to that key. We have a comma, and then the next key value pair, comma, next key value pair, and so on. And you can see that when we want to access the elements of a dictionary, we, rather than putting in the index values, or rather than putting in the integer index value for each of these different things, we actually have to use the key name in the inside of the square braces. And if we don't have a particular key inside of the dictionary, then we're going to see an error that tells us that that key doesn't exist in that particular dictionary. To sum all of this up, Python has a number of different built-in types that we can use for our own programs. The most common that we've looked at for now are numbers and different kinds of sequences. These sequences can all be indexed or sliced in order to access smaller parts of the whole. We saw examples using strings and lists and tuples of how we can do that. One thing to remember is that lists can be changed, that is to say that they are mutable, whereas strings and tuples cannot be changed once we've created them. They are immutable. That's all I have for this lesson. I hope you found it interesting, and if you have any questions, please don't hesitate to post them to the discussion forum on Blackboard. Thanks. Bye.